Hello, everyone. Welcome to April's TBC Power Hour. The topic today is WYDOT, which stands for the Wyoming Department of Transportation, presents roading workflows with TBC. The presenters are myself, Joe Blecka. I'm the TBC Product Manager based in Westminster, Colorado, and very happy to have Andrew Klingenberg with the Wyoming Department of Transportation doing most of the talking and the presentation today. Thank you for joining us, Andrew, and thanks for your preparation for this.
Thanks, Joe. Yeah, as Joe said, I'm with WYDOT. I'm a district project engineer here. Basically, I am in charge of our construction surveying and our construction division from overall direction of where we go with our surveying to training support, equipment, whatnot. So the agenda we've got laid out today is going through some of the different methods and formats that we use at WYDOT for road stakeout, what processes we use to generate road staking data. We're going to go through a demo of one of the workflows that we do, and then we'll have a Q&A session after that, and then Joe's got some more information for you after that Q&A.
Yeah, and so throughout the presentation, if you've got any questions for Andrew, go ahead and type them in. We'll log them, and I won't necessarily interrupt Andrew, but if there's a time to ask them when it's particularly applicable to what Andrew's showing, I will. If not, we'll get to them at as many of them at the end at the Q&A session, and we will have them logged so we can follow back up with you afterwards.
All right, thanks, Joe. So the first thing to go through is the different formats that we at least use at WYDOT here for staking out road designs. The first being using Trimble Road XML files or RXL corridors, templates, and string lines. Also DXF line strings and TTM surfaces. And we'll briefly go through some of the advantages and disadvantages of each way of using that kind of data. So starting off first, using the RXL corridor model, this works best when you have a design that all of your string lines and things that are part of your design are basically following off of a master horizontal and vertical alignment, like what the screenshot is here on the right side of the screen, where all of your string lines that form, in this case, we've got edge of pavements, curb and gutter lines, sidewalk, your slope lines. All of that is being defined by templates that are applied down that alignment. And in this case, we do have an intersection shown here, a fairly simple one. As long as that doesn't get too complex, we can still model that reasonably well with the RXL format using one road model for that main line that kind of flows east-west there, and then secondary alignments for that side road that we cut out and put in there as well. And the other way to carry the stakeout data for road designs is going through line strings and surface model. And this is more suitable in the example we've got on the screen here. We've got a roundabout where we have all of these different design elements that are mostly doing something more independent. Everything's kind of going a different direction. We've got different flow lines with their own alignments, sidewalks, islands, different lane alignments and cross slopes. And this kind of thing is very difficult to somewhere near impossible to model with a template based format like the RXL. And in this kind of case, we would have the break lines in the DXF file. Those would be our line strings, either 2D or 3D. And then we would use a surface in TTM format to elevate those line strings if necessary, and then fill in that surface between all of those line strings as well. So some of the reasons that we like to use the RXL file, the RXL corridor format, is it does preserve more of the original geometry of our design. It's easier for us to make some smaller design changes, especially things in the field. Even on Trimble Access, there is edit functionality for road XML files in there. So if we need to do some field fits, we've got some changed field conditions or whatnot we need to take into account. It's easier for us to do that. There's some more view options in Trimble Access. For example, as you're staking, you can see your cross-section view of your entire corridor, see where you're at on that, as the screenshots below demonstrate. One of the big ones for us is with an RXL file, you can slope stake this in Trimble Access. This is really the only way that we know that works efficiently for us to do that kind of operation. And that's one of the first operations we'll do out in the field when we start construction or even before construction. So the screenshots we've got on the screen here from Access, we have our own customized stakeout displays for roads. For example, as we're doing slope staking here, that show us in our standard what we would write on the front of the slope stake and the back of the slope stake if we're going to write all that information and put those stakes out there. And then as well, after we get done staking, for example, slope staking out in the field with Trimble Access, we can run road slope stake reports, either right from Trimble Access, or we can do it later in the office. For example, job report generator within Trimble Business Center, or the ASCII file generator. The screen on the right there shows we have our own customized style sheet for slope stake reports that we can run, and this just runs right out of the staking data that's stored in your job in Trimble Access. So circling around a bit, those are the advantages of the RXL format. Going now to the DXF in combination with the TTM file scenario. This one, as we demonstrated earlier, this is where we would go for more complex designs where we really can't use the road XML file format. But unfortunately, you end up not preserving as much of the geometry of your original design, particularly your verticals or any of your relationships between your design elements. In the road XML file, you can see everything that makes up your design surface, and you can see where things are at relative to other things. For example, when we're slope staking, we can see here's how far it is from our catch point to our hinge point to any of the next break points on that road surface. When we go this way to a line string and surface format, you really just see where you're at on that one element at that time. And then this becomes a bit more of a read-only kind of an operation once we pull it over into Trimble Access. We really don't make in-field changes. It's not practical to do. There is some editing we can do with line strings, but that surface model, if we start needing to tweak anything, we would really have to go back into the Office software and fix that there. So the typical processes that we use at WYDOT for generating road stakeout data, we use Bentley Geopack as our software at WYDOT, currently on Select Series 4. We have two different design methodologies right now that we use. One is our traditional cross-section based design. We still have a number of projects that we have that are using that design, but also we have been moving over into the open roads corridor modeling. This year we've been starting to kick out more of our new projects are being designed in that fashion. So for our traditional designs, We'll kick out a road XML file from those cross-section designs, the new corridor modeling designs. That really at this point for us means line strings and surface file for that road design data. And then our other workflow is more of our quick field ad hoc designs, where that could be a mix of different tool sets. We might be using some Geopack tools, Trimble Business Center, Trimble Access, combination of any of those, depending on what kind of data we've got in there. But typically, we would be looking for a road XML file to come out of that process that we can stake from. So what we're going to do now is run through a demo of one of these workflows. We're going to be using Trimble Business Center Survey Advanced version 4.10, which just came out yesterday. Is that correct, Joe?
Yes, great plug. Version 4.10 has been released and is available now online on our TBC website or via the check for updates routine via the start menu in TBC.
We will also be using Trimble Access, particularly the roads module, so 2017.11 version, and then of course our design software, the Bentley MicroStation and Geopack SS4. And so the workflow we're going to run through here, we're going to go through one of more of our traditional cross-section based designs, because we're going to highlight the road XML format in this webinar. So what this workflow looks like in general is we'll go into Geopack and do a brief design review, see what we've got, export the data out, put it together in Trimble format. Then we're going to take that into Trimble Business Center, pull that data in, look at it. We'll also go through some earthwork as well, and then also taking this data into Trimble Access, doing the same kind of things. How would we verify what we've got, and what files do we need to be ready for stakeout in the field? So first step, doing our design review in Geopack. So basically what we're going to look at in here is look at our alignment and template or cross-section information and just see what we've got in there. Identify what areas that we want to place in what road model. So for example, we might have a mainline file. If we've got some ramps or side alignments, those would be separate road models. What do we want to put in there? And one of the other things that we will do as well is the different surfacing layers on each road. We like to make a separate road model for each one of those layers. For example, top of dirt, top of different base layers, sub-base, crush base layers, rather than doing a construction offsets or dial downs to come down from a finish grade. We find that this really eliminates the errors from any kind of manual entries, any fat fingering, whatnot. It also allows you to do direct quantity takeoffs right from that road model for each layer. And then we also, if possible, generate a new profile for each layer as well. So profile for top of dirt, profile for the different base layers, so that we've got a clean surface to work from. So switching over into Geopack. So the design we're going to run through on this one is we did a new divided 4-lane construction. We had an existing 2-lane road. We're going to build a new northbound lane, which is what I've got shown on the screen here. And then we're going to take our existing 2-lane road and turn that into our southbound lane. And this one's about a 6-mile project. For purposes of this demonstration, we trimmed this down to a little over 1.5 miles, so that we can show this a little bit better. But we'll come in here briefly and look at these cross sections and see what data do we want to pick out. So for example, the first thing we're going to look for is our top of dirt model that we can go out and slope stake. So what do we need to do to get this grade following across these slope lines across the top of this orange line, basically encompassing this area that's all shaded in blue, which is our dirt work for the job. So we've got this northbound lane. We also have, I'm going to switch over to a different set of cross sections. You can see in green, this is where we would have built our northbound lane, because this project is in a couple of phases. We're going to do the new northbound lane first, then we're going to turn around and do a full depth reclamation and a bit of slope work on this existing road over here and make this into our new southbound lane. So once we do our review, see what we've got, our process in GeoPack, we're going to export our alignment out, export our cross-section information, put in a Trimble format, so that'll get us our road XML file we can use. A couple other bits of information that we will use in the field as well is design slope stake locations. So basically where we thought we were going to hit. And as well, we will export out the original terrain model, and this is for purposes if we find some things that aren't fitting out in the field. This helps us do some field checks and figure out where our original terrain, where we might need to do some fixes. We need to do some infills with our field work. So I'm going to switch back into GeoPack. So very briefly, I'm going to run through. We're going to export out our alignments. And in this case, because we're working with a GPK file, this is one of our traditional designs, we're going to push this out temporarily in Trimble DC format. So I'm going to pick my chain and profile that's going to represent what I need for my northbound lane. Give it a file name, export it out. Now I have my alignment information. The next thing I'm going to do is kick out information I need from my cross sections. So on this, I'm going to run a report on the cross sections. I have the file already set up to give me what I need, so I'm going to pick it. I'm going to run it. It's going to extract the information I need from my cross sections. The final step then is I need to assemble this into a Trimble file. So we have an in-house tool that we built that helps us do this from the GeoPack data. So I'm just going to feed it what I need. So all that data I just kicked out of GeoPack, I'm going to feed into this program.
While Andrew's doing this, he's using the DC file here and this proprietary, in-house software pack to get the data from the Bentley environment to the TBC environment. There are existing support for other formats. The DGN can be imported into TBC natively. The iModel construction DGN, ICM.DGN can be supported and read into TBC as well as DXF or the old trusted DC file like Andrew's doing.
Sure, thanks, Joe. And like you mentioned, Joe, that is one of the formats we use with our new designs that are in the Open Roads Corridor Modeler. Kicking out that ICM format and bringing in the Trimble Business Center as well, and that does work to bring that information over. So once we have that information assembled, we've got it put into a Trimble Road XML file. I'm going to switch over to Trimble Business Center here, and let's start looking at the data we've got. So the first thing I'm going to do in here, I've got a new blank project set up, is I'm going to start by importing my original surface. And the reason I'm going to do this is the road models that I have side slope instructions on them. And while they will import into Trimble Business Center, I won't be able to see them in a surface unless I have a surface for that to target. So I'll start by bringing in original ground, and I clip this original ground just to the area that we're looking at doing our new proposed road work. Our actual survey encompasses much more than this. So we'll bring this in first. Second thing I will do then is I will bring in my new northbound lane. This was our new reconstruct lane. And then near the bottom right, one of the settings for the road XML import is the target surface. And I'm going to tell it those side slope instructions need to target my original ground. And then I will import this. And this will take, 10 or 20 seconds to pull this in and make that new surface. So we'll give it a moment here while it completes its job. Okay, so I'm going to zoom in a bit around this. So now you can see I have my new northbound lane corridor, side slopes that are coming out and targeting my original ground. Now I have more than just my northbound lane. After I build this, we also have southbound lane construction. Now to pull this one in, the side slopes on it may be targeting either the original ground, or they could also be hitting our dirt work from our northbound lane that we just built. So in order for those slope stakes to target correctly, I need to have a new composite surface that basically encompasses both of these. So under the Surfaces tab, I'm going to merge surfaces, and I'm going to set this up real quick and get it running because it does take about a half a minute. And I'll explain what I'm doing as soon as I get it started here. So I'm going to start with my original ground surface. I'm going to merge in my new northbound lane top of dirt model. So that'll replace that surface anywhere that exists. And then my final surface name, I called it after northbound lane. So now I'm going to have basically an intermediate surface in my construction. And I'm going to use this to target my southbound lane. And we'll give it another 10 or 15 seconds here to complete the merge operation. It should show up here shortly. Okay, so now in red, there's my new merged model. So I'm going to go back to my import. Now I can pull in my southbound lane dirt model. And my target surface down in the lower right, now I'm going to target my surface that's after my northbound lane construction. And again, this is just going to take a minute while it triangulates everything.
Andrew, what's the size of this little stretch of road that we're dealing with?
The stretch of road that we've got for this data set, this is about 1 2/3 miles or so. The actual project was about 6 miles long.
And as you can see here in TBC, the data is all connected. So as surface members change or as features of that surface do change, you can set the surface to automatically regenerate, or you can set it to manually regenerate, user triggered.
So I'm going to switch back to our presentation here and go through, now that we have our data in, what we're going to be looking at for verification, just to make sure that our data is good before we go any further. So we're going to do some spot checks, horizontal, vertical alignment. We do spot checks on cross sections, particularly where we have odd things like section changes and whatnot. We're going to make sure string lines on the road are connecting up correctly between the templates. We're also going to look to make sure we don't have any slope interpolation issues. That's a screenshot I've got in the upper right there. For example, we've got something going a little goofy in that particular scenario. And also, the other one we look for is non-tangential horizontal alignments showing up in that screen from Trimble Access down in the lower right. While this is a rather extreme example, if you have alignments that have PIs in them without any curves, that can cause some strange things to happen with the templates. So we want to go through and just make sure that everything's working correctly with those road XML files. So in Business Center, basically we're going to do, we just pulled in our data. We're going to go through looking at the corridor definition report, do some spot checks, cross-section views, go through the 3D drive-through, and look at the earthworks that are going to be generated as part of this. So back into Trimble Business Center. One of the first things that I do that's handy as I'm looking at corridor models is in the lower right corner of the Business Center screen there is the coordinates display. If you click on this, you'll get a coordinates window, and there's some options in here you can change if you right click on it. By default it has grid coordinates, surface elevation, station offset, and template end areas turned on. So if we come in here, and this will show whatever you have last selected for station offset and elevation. So if I want to look at my northbound lane, if I select my alignment of my northbound lane and my corridor surface for my northbound lane, now as I scroll around with my cursor, you'll see on that coordinates window I can see my station offset and elevation from that particular corridor. And that's kind of handy if I'm looking at something on the screen, just to be able to scroll over it and see where I'm at very briefly. The other one is having the View Filter Manager. If I scroll down near the bottom of the surfaces, dynamically turning these on and off so I can clean up this display as I'm reviewing things. So if I'm going to go through and just review these roads, I'm going to turn off my original ground surfaces so I can just see my proposed models on here. So now that I'm looking at these, some of these checks, like you mentioned before, a lot of these are just visual, looking at, do these string lines connect correctly? Does everything look right? How is my side slopes tying into my original ground? All of that. If I need to go into a particular part of the corridor and do some edits or modification, I can click near where that template's assigned, where those yellow squares are at on the screen. I can highlight that template. I can right click, edit, and that will bring up a cross section of my corridor down below on the screen, and I can look at all my template instructions that go into my corridor at that particular point. So if I had some issues with, for example, these string lines aren't forming correctly, these string lines basically are node 1 from one template goes to node 1 of the next template to number 2 of one template goes to number 2 of the next template. So if we need to change how those connect, we may need to insert some additional nodes into one of these corridor instructions to change the way that these lines form if we do have some issues. So that's one thing that we will look at as we review in here. I will close out of this view now. One of the other ones, under the corridor tab, there is a corridor definition report. And for example, if I want to run this against my southbound lane, I'll say OK. The lower part of the screen, it'll pull up the definition report, and this is one thing that we can use to go through and do some spot checks of the horizontal alignment, vertical alignment, scrolling through if we need to do any spot checks against our templates from GeoPack. I'll give this just a moment to load up here. It's taking a sec to generate. So I can flip through. I have my horizontal geometry, my vertical geometry. We've got a few pages of that. And then it goes into all the templates to define this road. So if there was something I wanted to just verify, make sure everything transferred okay, I can go through and check it in this report. One of the other handy review tools is in the corridor tab under the view, there's a cross-section view. And if I want to look at a certain area, for example, in this area where I've got some overlapping earthwork, pick the area I want to go in the plan view, and then in the cross-section view below, I can see my different surfaces. I have lower right surfaces button. I can pick what surfaces I want to see. So for example, I want to see my northbound lane, my southbound lane, and my original. And it's looking like it's retriangulating something here briefly. So I can, nice handy way to look at what I've got going on with my dirt work in this area and how my different phases, for example, my northbound lane and my southbound lane are interacting with that earthwork. The other one we're always big on, visualization is a really good design check, is going through the 3D drive view. So in the corridor tab, in the view 3D drive, the first thing we'll need to do is select our alignment that we want to look at our drive view on. So I'm going to pick my horizontal alignment for my northbound lane. Click into my 3D drive view. And we've got a lot of extra alignment here because I had trimmed this example down for a demonstration. So I'm going to scroll forward with the scroll bar on the bottom till we get near where our design starts. And I like to change a couple settings in here real quick to make it easier for me to look at. So there's the gear icon for the 3D drive view settings in the lower right. And I like to change my alignment height, put myself up a little higher from the road, let's say around 15 feet or so. And this view filter manager, this is active. We can change whichever view we're in at any time. I'm going to turn off some of these surfaces. I need to be into my filter so I can change this. So if I just want to start off in my 3D drive view looking at my northbound and southbound lanes, this is what I can do. Set a speed and start driving through. We can see any of the surfaces or our corridors that we've got up at the time that we're going through. I can leave this running. I can click on these surfaces. For example, if I want to see where my original ground is, I can click this on as I'm driving. completely dynamically. So for example, we're coming through an area where we're cutting out a bit of a hill here, going back through it. I can turn that off, see where I'm at just on my roads again. In my top plan view, as I go, there is a car icon you can see here showing me in real time where I'm at on my roadway in my plan view as I go through this. So another nice tool that we like to use. You can stop at any point down this drive view, turn yourself around, look around, see what's going on with your design. So then the final thing, if we're happy with our design, I want to look at earthwork quantities briefly with this. So before I do my earthwork, what we do at WYDOT, when we compute our dirt work, we have to take into account our topsoil stripping. And our original terrain model we pulled in is just that, just the original. So I need a model that represents where we have stripped topsoil if I want to actually get a good earthwork quantity. So what I'm going to do here is import that surface. And what this looks like, I am going to go back into my cross-section view here, and I'll turn this surface on so we can see what this looks like. So this is the surface that is basically, we've offset it, in this case about ½ a foot down, representing where we have stripped topsoil in that model, and where we don't strip it is where we have sections of existing pavement. For example, where this existing roadway was, there is no topsoil stripping, but the rest of the project we do have that. So now that I have that in here, I can go into my reports, my earthwork report, and this is going to be a surface-to-surface volume computation. I'm going to start with my original ground that I have stripped my topsoil off of, and let's look at our proposed dirt grade for our northbound lane model, which was our first phase. We'll generate the report and give it a moment to do its computation, and then we'll get a window coming up with our results. Running through, looks like we're almost done here.
Yeah, I've got a good question here. Can you use different colors in the display of surfaces? And I can take that. The answer is yes. In the properties of a surface, you can specify different colors, different solid colors, or just that wireframe view on or off. A couple of different options, shading options, triangulation options, in both plan view and 3D view, independent of each other.
Okay, so our earthwork report is complete. What we look for, so in this case, on our portion of our design that we looked at here, we've got, shows what we have for cut and fill in that section, also shows areas for those relevant cuts and fills, and also shows a summary of how deep was our maximum cut and how deep was our maximum fill, which is kind of nice for a brief QC check as well. In this case, this does look about correct for this design. So very quick and easy to get earthwork quantities out of Business Center for these corridor models. So then the last thing that we'll look at is what this data looks like in Trimble Access, getting us ready to stake this out in the field. So we'll look at, in the roads module, the alignment definition, look at the string line and cross-section views. There's a 3D drive as well in Trimble Access, and then briefly looking at what's our stakeout data look like that we're going to take out into the field with us in Access. So we're going to flip over into Trimble Access Roads module. So if I go into Define, and I'm going to look at my northbound lane dirt, some of these same spot checks that we did in Trimble Business Center, we can also do in Trimble Access. For example, we can look at our definition of our horizontal alignment, check and make sure everything is good here. Same way with any of our other components that make up this road. But really what I like to do is go into the review soft key at the bottom, and we'll zoom in around our design. Once we get closer, we can start seeing the string lines that make up our design. And I can come in here, anything of interest, I can click on specific points or specific string lines and look at the coordinates of that. Once I have selected a point, I can go into my cross-section view icon on the left and see what that particular cross-section looks like. Click on different components of that in Trimble Access, and also if I need to do a quick review and whatnot in here. In this review option, there is a 3D drive view in Access as well. This basically just takes you a really quick run through. Not many options here, but it is a quick review tool as well if you need it, and got it running right now. We're just going down the first portion of our alignment where we don't have any design yet. And now we hit our design and we're flying through it. We can stop and start as we go and just do a quick view of it that way. So now looking at what data I've got to run my stakeout with, so I'm going to flip over into my map in my general survey. So I have my northbound lane and southbound lane designs pulled up here, and also all the labeling on here. I have all my design slope stake points in here that I'm going to try and hit. This is useful to us, even though we've got the side slopes in our road model. Sometimes we do things like daylight cuts or daylight fills where there's more than one area out on the ground that we could potentially catch our road model, and we want to make sure we get out to the right spot. So we'll use these as a starting point when we go out and stake from, and then adjust as necessary from there. So I have this data in here. The one piece I don't have pulled up on here, but I do have it available for me if I need it, is also this original ground model that I can use to verify any of my original terrain in the field if I've got any issues on it. So at this point, I've got my road models with side slopes in them, my design slope stake points. I'm ready to go out and do my slope staking and grade checks from there. So that is a run through of one of our typical processes and showing what we can use, the tools that we have in Trimble Business Center and Trimble Access to verify and do some computations and do some stakeout from those. So with that, I'll turn it back over to you, Joe, for the Q&A part of it.
Yeah, we've got a couple of really good questions coming in here, and we'll have time to address them. A question came in about other formats. So this workflow specified how TBC and how Trimble Access fit within the Bentley, the GeoPack roading workflow. The intelligence of the alignment and cross sections, for example, is also supported with the Land XML format if you were working in separate packages and can generate the Land XML as well. I got some really good questions from Molly, and she asks a couple of things here. So, Andrew, in your workflow, who typically processes the design data and the surfaces in TBC? Is it the engineers or is it the surveyors?
So to create the original design data, for example, those road models, that could be either our designers or it can be some of our field personnel out in construction. It depends on how comfortable those folks are with doing that out in the field. As far as making those. Now, once we get to that point, any of the subsequent things that happen after that, um, looking at earthworks and business center, doing any of those kind of computations, any of those changes, that is all on us in the field side or the construction side.
Okay. And then as kind of a follow-up to that, who then verifies the merge data in TBC or Access? Is it the engineers or the surveyors?
It would be the engineers out in the field would go through and look at that in conjunction with the surveyors as well, bringing that data in if we had any changes out in the field, making those edits into those models to make them correct. But yeah, that is the field engineers that do those.
Okay. And in your example and then your typical workflows, are the super elevations exported and used to prepare the stakeout data?
So super elevations, that comes through as part of all of the cross sections in this case in our traditional workflow, or if this was a design with the new corridor modeler, it would come through as part of that. It's not actually shown as super elevation as such in the road XML file. Everywhere that super elevation changes, just for us, is just different template definitions is how our workflow works.
Okay, so then do you then stake out those interpolated sections between the design stations, or is it primarily just along those stations that you've designed?
We can definitely do either. Anywhere that those super elevation transitions occur, we would be staking those out in the field, and those would also be shown in our design as well. Anywhere that there's any of those kind of transitions, whether it's super elevations, widening transitions, section changes, any of that kind of stuff. And we can also stake as needed between any of those. When we go through and generate these, we do try and make sure that let's say they're as complete as they can be. So if we do out, whether we're staking or doing grade checks, if we've got automated machine guidance doing the dirt grading, that we can wander out anywhere on that road and verify grade, not having to worry about being on a particular station or section to make that correct.
Okay. A couple more here. Oh, the slope stake points that you have in Trimble Access, how are they generated? How do you generate those?
So those, I do actually have a screen open. I can show that quick. So in MicroStation, these design slope stake points, I'm looking at the plan view of our design. I've got most of the levels turned off except for the center lines of the two alignments. And the other lines that are shown here are basically our limits of construction or our tie down points from each one of those. And basically we'll just export this line work or these vertices from this line work. That's where all of those design slope stake points come from. So all these vertices on these tie down lines, we'll elevate that against the original terrain model and then export that out as a CSV file. So 0.9 northern easting elevation feature code.
Okay. Got some questions on TBC and the RXLs. So Jean-Michel asks, is there an easy way to export the alignment only for a small part of the template. Like you said, your entire alignment there was 6 miles or so long, but we were just dealing with 1.5 or 1 2/4, or 2/3 of a mile. And so the answer, Jean-Michel, is yes. And something that I do want to showcase here, because there's a couple more questions on the RXL. Andrew, if you wouldn't mind going into Home tab and then Export. And then in the corridor subtab there are a couple of different RXL options. One is the top one there is Road Exporter from Alignment. So you can see here that would just be exporting your alignment in horizontal and vertical, and you've got the ability to specify a begin and an end station. We did make a concerted effort. It was 2 cycles ago, I want to say, to improve and clean up the RXL export that has the entire corridor, all of the cross-section information with it, and that has been renamed to the Trimble Access Road RXL templates export option. And so again, this would include everything on that road associated with that corridor, with a beginning and an ending station. Also common in various places in the world, mostly in New Zealand and Australia, that we've been familiar with, is that option, the next option, Trimble Access Road Strings. So string-based exports, where along every interval that you set, you get road strings. So you've got a center line, you've got your edge of pavements, you've got your edge of shoulders and whatnot there. So those are the primary options for exporting and getting into Trimble Access Roads. And Trevor asked a question here early on, what instances are the RXL format not suitable? Well, the RXL format is really for corridors, and so they're kind of linear based. And Andrew had a couple of good slides here right at the beginning where he showed an example of an intersection, for example, where there's a lot of irregular or specific geometry, nothing that you could do with necessarily an easy template. That would be an example of something there. Thank you, of a situation where RXL would not necessarily be the best choice. Let's see, what else do we got? Couple more coming in here, great. John is asking, can you show how you create that drive-through again?
Definitely. So on the 3D drive view, move my windows down a bit. Actually, I'll just close out of this cross-section view. So starting with my plan view, where I have my corridors and surface shown, the first thing you need to do, so I'll go under my corridor tab at the top. So under this 3D drive view, the first thing it's going to need is what do you want to drive down? What's your path going to be? So the first thing I'm going to do is select my alignment, whatever I want to use on here. For example, I'd used this horizontal alignment of my northbound lane, and I just selected that with selection tools in Business Center, and then came into the 3D drive view. And it will start off at the very beginning station of your horizontal alignment. And what I had done is scrolled through these stations at the bottom with this slider until I get closer to my alignment in here. And then again, the tools or some of the drive settings are in that gear icon on the lower right. Like I had changed my viewpoint height. I like to bump it up a bit so I can look down at that surface a little bit more. And then using that view filter manager as well on my surfaces to turn on or off, whatever I want to see as I'm looking down that roadway. And then it's just a matter of if you want it to automatically drive down that road, you can give it a speed and hit start, or you can manually slide that around to move yourself down that road. And you can always pan and move yourself around, zoom in and out in this 3D drive view as you go as well. So does that answer that, Joe?
Yeah, and while we're here, we've got time for one more. There's a couple more here still coming in. And we'll get to those offline here. While we're in here, you mentioned the View Filter Manager. Question came in is, can you display different things in different views? For example, have two plan views open or two 3D views open at the same time? The answer is yes. If you see in the plan view that Andrew has up top, it says plan view and then in brackets, my filter. Same thing with the 3D drive view in brackets. It says my filter. That corresponds to the view filter that's actively applied right now. And to the left there in the view filter manager, you see that my filter is selected. You can create your customized filters and have multiple filters going that are governed by those subsequent checkboxes below there along the left-hand side. So yes, the answer is you can have multiple views open with the ability to show different things. If you just wanted one view to show the surfaces, or if you just wanted one view to show line work, or combinations of thereabouts, that is possible in TBC. All right, thank you for all of these questions. We will get to them. I've got them logged, and we'll get you offline here. With the couple of minutes we have left, I'd like to go through some resources and kind of next steps, what we've got planned for you with TBC and these power hours. So one of the things that we've really tried to take a big effort for is getting these resources out to you, our customers, our users. We've got a newish website that has much more interactive content and resources, and it's easy to remember, trimble.com/TBC, where we have a lot of customer success stories. Don't believe my word for it. Believe guys like Andrew and other users that we have videos for. There's also a pretty slick TBC overview video. If hopefully we've piqued some interest seeing the capacity of what TBC can do. It's about 120 seconds of everything that TBC is in a quick slick overview video. Go ahead. Our YouTube channel, like I mentioned, we've got a release out yesterday, very exciting, TBC version 4.10. Check for the YouTube channel. There's a overview video I posted that has me talking about all of the new functionality that we've added in TBC. There are workflow videos, just a couple minutes much more digestible than my marathon session of introducing everything. The major features will have 3, 4, 5, 6 minute videos of what's new in TBC. We're also looking to reorganize this based on workflow rather than by versions of what's new. These power hours started in 2015, so there's 40 or so of these sessions. They are all recorded and they're all available for you to watch for free. On demand. We've been getting into lately being able to post the data and the presentation, and the same with this. We'll be able to share some data with you, post these slides, so you can follow along, pause, fast forward, skip around, digest this information and everything that Andrew showed today. Our TBC community page is sort of our public-facing blog type of a community. We have our tips of the week. I've got 2 of them coming out this week because I didn't do one last week. Just kind of little quick hitters on, hey, I didn't know TBC could do that, or oh, that was interesting. That's something that I didn't know TBC could do. I'm not a huge social media guy, but it is nice to share announcements. Everybody's, Facebook has such a dominant presence in the social media space. We've got our Trimble TBC page on Facebook that we use for announcements. And so next steps. Hopefully you've liked what you've seen here. This webinar was exciting to put on because it shows our commitment, Trimble's commitment and TBC's commitment to play nice with others. The Bentley and Autodesk are firmly ingrained and entrenched into the DOT space, the roadway design space, and we want TBC to complement those workflows. We're not trying to compete with Bentley and Autodesk in the civil design space, but we're very happy that there's a value that TBC provides, like Andrew showed, linking that design world with the field world and doing QAs and reportings in TBC. So the download is free. You can get a free 30-day demo license from your local Trimble distribution partner. We are global, and you can use this new locator tool to find who's closest to you if you don't know who your local Trimble rep is. And then lastly, and certainly not least, our next TBC Power Hour, we've introduced a new tunneling module that with initial humble requirements of being able to support Trimble Access tunneling application. We've added a lot of value for tunneling customers. We've introduced that with version 4.10 yesterday as an add-on module. I'm going to have Adam Tigris, who has done a lot of the development along with me and the testing on this, and see if we can get another end user guest host with us. But we're going underground in TBC with tunnels on Wednesday, May 23rd. So look for registration links for that as a great introduction into our new application of tunnels in TBC. So with that, again, we've got your questions. Thank you very much for your time and listening to us here. Hopefully you've learned a couple of nice things. Andrew, I can't thank you enough for what you've put into this. Great job. And do you have any closing comments?
No, I just thanks for the opportunity to showcase some of what we're doing, Joe, here at WYDOT.
Yeah, absolutely. Really great job, Andrew. And we'll be in touch. And if you like what you see, free in another couple hours, we're going to do the same show again. Otherwise, hope to see you next month as we talk about tunnels in the TBC Power Hour for May. Thanks, everyone. Have a good evening. Have a good rest of your day.